All right, welcome everybody on this Tuesday afternoon. You are almost halfway through with the conference. Congratulations. Welcome to All Your Tests Are Terrible, Tales from the Trenches. This might also be titled The Titus and Hyrum Show. I'm Titus Winters.
I'm Hyrum Wright, and together we work on, or among others, we work on the C++ library infrastructure at Google. So we spend a lot of time dealing with other people's code and seeing other people's tests and cursing other people's tests. And so this is something of a confessional session, as well as hopefully a learning session as well.
But we don't really want to be just pointing fingers at Google engineers or anybody else. We understand how bad tests happen. It's okay, right? But we would like this to be educational and kind of point you in the direction of having some better practices. So to that end, we're going to introduce our guests for the afternoon. You may remember them from such things as being 6 years old. This is Goofus and Gallant. How many of you remember Goofus and Gallant? A few of you, all right. These were kind of comic figures, like in the literal sense. Not that they were actually funny, but they were in comics. I knew them from Highlights for Children, and they're kind of this like preachy, Goofus does a bad thing, Gallant does a good thing. Turns out, we've followed them through the years, and they grew up to be software engineers. So we will describe the software engineering practices of Goofus and Gallant over the course of the talk.
So there are 5 properties of tests that we'd like to talk about today. They aren't the only properties of good tests, but they're 5 that we've identified as tests that have these properties are good for your code and will help you actually test correctly, right? So
we're going to start with correctness. This is kind of the number one, well, maybe number 2 thing that you're really looking for in a test, right? This is testing that your API is actually behaving correctly, right? Good place to start.
So the second one is readability, right? Your tests actually don't have tests of themselves, and so your tests should be readable. They should be correct by inspection to both yourself as well as another reader, which may be yourself in like 3 weeks, right? So we want to make sure our tests are readable.
We need to make sure that tests are complete, right? That is, you can't just get away with writing one quick test, one demonstration of an easy case and call it good, right? We need to make sure that you have tested completely through your API and only your API.
Also, tests are a great opportunity to demonstrate demonstrability. See what I did there? No. So tests give you the opportunity to show how an API should be used, and if you can't write tests without shortcuts, maybe it's not that great of a test.
Maybe that's not that great of an API.
Maybe it's not that great of an API either.
Right. Also, and this is going to be kind of our favorite part of the talk, resilience. This is the notion that your tests should only fail if the thing that they were actually intended to demonstrate became false and should fail for no other reason. This is kind of critical. Okay? So, but all of that is kind of, these are goals, these are ideals, these are things that we want all good tests to have. But in order to have properties of good tests, first off, you have to have tests. So, Goofus doesn't write tests.
Gallant actually writes tests.
Right? This is step 0.
Right. If we learned anything from CppCon last year, it's that we're having trouble writing tests as a community, right? So if you aren't writing tests, none of the rest of this talk actually applies very much, right? So go write a bunch of tests, come back and watch the talk on YouTube, whatever, and take these principles to heart, right? But please, write tests.
Right? This is non-negotiable. Okay? Write tests.
Don't be Goofus.
Yes. Okay? Goofus will just write any test that passes. Right? It's green, must be good.
So Gallant takes the opportunity to actually think about what he's testing, right? To think about what is the purpose of the test and what the test should actually be testing.
This is getting at correctness, our first major bullet point. Right? Tests must verify the requirements of the system are met. Goofus instead writes tests that depend on known bugs. We have certainly seen code that is morally equivalent to this.
And many of you probably have too, right? So Goofus writes the square function, which is undocumented, but assume for a moment that it squares an integer, right? And then he writes the corresponding tests. And he's very happy because these tests pass.
It's green, it must be good.
We can go home, right? No, we cannot go home.
You can't go home. Right.
So
I really, truly hope, number one, that your organizations all are writing tests. That is number one for sustainability. I will give a whole talk on this later in the week. Number two is you have to have code review and you have to take it seriously. So hopefully a test this blatant never gets into the code base, right? Even if your code reviewer skipped double-checking Goofus's work on Square, he sure as hell should have validated that the test makes sense, right? So hopefully this was caught in code review and the tests were fixed, if nothing else.
So hopefully Gallant comes along, fixes Goofus's poor tests, but now we have a problem, right? Gallant has just caused the tests to fail, right? Everything is red, pagers are going off, build cops are screaming, right? The tests are failing. But where is the bug? Is the bug in the tests or is the bug in the implementation, right? As an organization, you need to make a decision. Whose job is it to fix? When a test fails, do we just blame the guy who caused the test or the programmer that caused the test to fail? Or do we think about why is this test actually failing? Is the test now more correct? And what does that tell us about our actual implementation?
And when you start approaching tests with an awareness of what the goals are, correctness, among other things, then you can start to have a mechanism to look at the change in question, updating this test, and decide rationally who should be blamed when the test goes red, right? And whether or not you need to roll back, and et cetera, et cetera. Rolling this back is not going to help anybody.
You can guess who gets lots of the blame at Google sometimes.
In theory, we're not pointing fingers.
No.
Goofus also has a tendency to write tests that don't actually mean anything. They don't execute any sort of real scenario.
Right, so imagine this case in which, for some reason, you're testing the world. And the world is a very expensive thing to set up and build and use in your infrastructure.
Takes days.
It takes days to create the world. So you mock out the world, right? Create a mock world that has maybe slightly different characteristics than the actual world, like maybe it's flat. And somewhere in your test, you start depending upon this fact that the world is flat in your test environment, right? Now, that's all well and good if you're shipping a flat world to your consumers, right? Presumably you're not, and you're actually using a real live system. And in that case, you've created an environment in which you're not actually testing the actual system under test, right? You're testing the fact that your mock actually works correctly, right? You're not actually testing the system.
Right. This test just has no point. Right?
Yeah.
Moving on from correctness. Goofus does not think about the reader of his test.
Gallant takes the opportunity to understand that his tests are correct and writes tests to make sure his readers know that they are correct. One of the reasons that we focus a lot on readability, incidentally, is because your tests will be read many more times than they are written.
Like all code.
Yeah, presumably you're only writing the test once, maybe run many times, but it will be read over and over and over again by you or somebody else, right? So optimizing for readability is actually a win, even if it takes a couple of more characters, gasp.
So some ways that Goofus has failed at writing nice readable tests. Goofus has a tendency to write tests that have lots of boilerplate and other distractions. This is a little hard to come up with slide code examples for, but it's not unusual to see a test like this. You have, okay, my test, this is a test of big system, and according to the top, the point of this is that some call is actually unimplemented. Then I have a whole bunch of setup. I'm setting up a storage system. I'm setting up my thread pools. I'm getting things started. I'm initializing the system. Oh, and there is one thing that is actually pertinent to the purpose of that test. Right? That is completely lost in the noise. Right? It's very, very, very hard for a reader of this test to separate like meaningful, important part of the claims that are being made by the test from just the rest of the line noise in the setup. Right? In this instance, we have significantly hampered readability by just cluttering the whole thing up. Goofus can also, on alternate Thursdays, go completely the other direction and hide all of the relevant context far away from the test itself. This has a tendency to look like this. I'm going to test my big system. There is some function that initializes the test system and all of the test data. It's hopefully somewhere in this file, but maybe somewhere else in some other library for test setups. And then I'm going to assert that the private key is 42. Is this correct? Who knows, right? There is literally no way to tell whether or not this is behaving as intended. And a good test should be correct by inspection, right? At minimum, a code reviewer of this test should complain rather loudly that there needs to at least be a comment saying it is part of the API guarantee of initialized test system and test data that the private key that is set in here is 42, right? But it's probably better to just restructure the whole thing.
So the other pitfall in this is to use the advanced features of your test framework, right? We're all engineers, and we all like to use new shiny whenever it comes along. And this can apply to advanced features in your test framework. So imagine a test that looks something like this. Right? The actual test is down here at the bottom. The test fixture, we're using gtest throughout these slides, which is what we use internally at Google. And so this is the test fixture for the test, right? And you can see there's some, we have some setup code. We have a constructor to the actual test fixture. In fact, I think the next slide has the, yes. Yes, there we go. Right, so gtest actually gives you multiple ways of instantiating test information, the test fixture itself, right? And we're using both of those ways here. Why? Because we can. Why not? Right? The other problem is that big system down here is a protected member of the test framework itself.
But it isn't referenced anywhere else in the test class, right? We're not calling anything on it, right? We're just constructing one and we just have it, right? So that's kind of funky. I'm pretty sure that all of the whole test is completely identical to this as far as the test passing goes. The part of me that's not 100% sure is the question of whether or not writing data, specifically the string hello world newline, into the file foo_bar_baz has some weird undeclared impact on how big system initializes. Right? If this test doesn't pass, then clearly there's something going on in the loading file system state, et cetera, et cetera, et cetera. And we need to do that, but we can do that explicitly right here in one line right in the test, and that's going to make everything far clearer. Right? You see that? Right.
So there's a balance to be struck when writing tests, right? Tests should read like a novel.
I love a test like I love a good novel. It should have a beginning, a middle, and an end. A novel should introduce its characters. A test should introduce the setup, right? What is your test data? What is your initialization? A novel progresses with, the plot. Your test progresses with actually calling the thing in question. What is under test? Your novel concludes with everything kind of wraps up. The hero defeats the villain, the girl gets the boy, et cetera, et cetera. Your test concludes with, given those setups and the call, you should have clearly that end result, right? Much like it would be bizarre in a novel for you to have set it up as a total, romantic comedy, and then in the final act, a dragon swoops out of nowhere and eats the protagonist. It's kind of weird when we can't tell in your test why the results are what you're claiming them to be.
It's kind of like if you have to jump back and forth all over your test fixture or different files to find out what's going on, it's kind of like reading a choose your own adventure from front to back.
Yes, that. So those are thoughts on test readability. Goofus writes tests for 2 simple cases and then goes running with scissors.
Gallant uses his scissors to create nice tests that demonstrate edge cases, right? That he thinks about what is the domain of my test, my system under test, and where do I need to test that? Where could it fall down? As programmers, we are really, really good about knowing where the pitfalls are in our systems. And we're really, really good about not writing tests for those pitfalls. Because then you have to go fix the bugs, right? So imagine Goofus writes the tests for only the easy cases, right? So, this should get past code review, I guess in some respects, right? It's correct by inspection. Only the implementation looks something like that, right? Goofus has written the minimal implementation that will pass these tests, right? What does that say? It says that we need to think about writing better tests, so the implementation has to be a little bit more thorough.
Gallant, on the other hand, does a thorough job. Gallant includes those simple, basic tests, but also includes edge cases like 0, edge cases like 12 factorial is as large as you're going to fit in a regular int. Factorial of 13 overflows. Let's make sure that we got back whatever we're specifying for that. Let's make sure there's no internal state that gets screwed up once you go to overflow. So we'll call factorial 0 again, just to be sure. It's not going to cost us much except for, 10 CPU cycles or whatever. And test the crazy cases. Factorial of a negative number. I had to go look it up on Wolfram Alpha. I don't know what it's supposed to be, but apparently infinity is good. So,
right? You don't have time to comprehensively test every single input, especially for any non-trivial function, right? But think carefully about the edge cases that you want to test and where the discontinuities in your inputs may lie, right? What kind of test cases will generate interesting results, and in some respects, what kind of edge cases your users are most likely to encounter. Those need to be in tests.
Right. I find that as engineers, as programmers, eventually as engineers, as programmers, we really desperately want the code we just wrote to work. And it is really kind of antithetical to all of our hopes and dreams to then go write tests to try to poke holes and demonstrate that it didn't work. And this is a reasonable impetus for write tests first, because then you don't have to be so antagonistic with what you just created. But yeah.
You're saying there's a little bit of Goofus in all of us, aren't you?
Yeah, we'll go with that.
So the other part of completeness is making sure that you only test the things that you are responsible for, right? So the author of this test, presumably Goofus, decides that, it's really important to know whether vector functions as advertised.
This is part of my filter function depends on vector, so I need to write tests for vector as well.
And they're not even segregated. It's like in the same test method, right? So as part of my test for filter with vector, I'm going to make sure that I can add stuff appropriately to the vector and that it behaves as I expect it to, right?
The question here is, where do you draw the line, right? If he's not trusting that vector works, why is he trusting that his allocator works? Why is he trusting that the compiler works? Why does he trust the operating system works or the CPU? Why is there not something in this test to mystically validate that his processor is working correctly, right? Where do you draw the line if you're not drawing the line at what you implemented?
It's perfectly reasonable to want to make sure that vector works, but in the test for filter is the wrong place to do that.
In the tests for vector is the right place to do that. Hi, standard library guys. So Gallant only writes the tests that make sure that his API behaves correctly, which in some instances is also exercising vector, but that's not the intent of the test. That's a side effect of the test. Okay? Goofus uses private APIs in his tests in ways that users couldn't.
Tasty. Gallant uses tests to show the ways that his APIs should be used, right? And this plays into the concept of demonstrability. Tests should be a tool by which you can demonstrate the proper use of an API to your consumers, right? So Goofus violates that principle in all kinds of ways, right? He writes tests that depend on private methods. He writes methods that, or he uses friend to make sure his test can twiddle secret bits inside of the class under test. Not really good ideas.
And when you find that your tests are doing this, this is highly suggestive that your API is probably bad to start with. We'll demonstrate.
So, this test, Goofus wrote this.
Not a good plan.
He's testing class foo, right? And he's added a special shortcut method, right? That can only be called by his tests, and that does some kind of special initialization just for testing, right? No consumer is ever going to be able to call this, and he's not actually testing his API the way that an actual consumer of that API would.
This means that even if he happens to get most code coverage, he's really not testing this class in the same way that his users are going to use it, right? Those tests may not mean much. It would be far better for Goofus to just write the test in terms of the normal API and drop all the rest of the cruft. Oh, I had a thought. I lost it. I don't know where I was going. I'll skip it. And then our favorites. Goofus just writes tests that depend on any feature of any interface that he can find.
Gallant writes tests that only depend on the published API, right?
There are many ways to screw this up, and Goofus loves to do all of them. Goofus loves flaky tests. That is, tests that when you rerun them, give you different results.
Has anyone ever seen these before in the wild, in their system? Okay, good. We aren't alone, Titus.
Oh, there are people that have seen tests.
Yeah. Indeed.
Yeah.
Indeed. Right, so this plays into the concept of resilience, right? Tests should be resilient. So we talked about flaky. Brittle tests. Tests that are brittle are kind of like balanced, 17 rounded spheres on top of each other. And if one of those gets slightly out of kilter, the whole tower falls down, right? Brittle tests depend upon implementation details of methods that you don't have any control over.
Or any business depending on.
Or any business depending on, yes.
This Tests is where that depend on execution ordering, we'll demonstrate, but you can kind of get this gist. Mocks can be a big problem, and non-hermetic tests. But let's start with flaky. Goofus writes flaky tests. These are the ones that, when you rerun them, the behavior changes, right? So we have definitely seen tests of this form. We're going to do some sort of async update, and I'm going to wait until it's done. There's no coordination, synchronization, signaling, anything like that. I'm pretty sure that should be quick, half second will be plenty. This test fails all the time when your, say, test cluster has a high load, right? As soon as the operating system starts thrashing or your scheduler goes out, problems, right? Don't write this test.
What are some other reasons for flaky tests? While we were on this slide, I'm trying to think of the other. It's not just async, waiting for async, right?
Clearly it's not.
I mean, we see flaky tests for timeout reasons. We see them because people are reaching out to touch production systems when they really have no business doing that. Yeah, right. Hermetic environment. Flaky is actually a symptom of lots of these other underlying causes.
Right. Brittle tests, on the other hand, if you rerun them at the same build, they're going to pass the same way. Like, they are nice and, they aren't necessarily flaky. They're bad in a different way. So for instance, Goofus may have written something like a tag set. It's something like an unordered set under the hood. He puts some data in. He makes sure that he can get the data out. He's confused why the data comes out in a different order, because he hasn't really thought through what an unordered set means. He's not so good at names. And so he's kind of scratches his head and moves on.
Gallant, on the other hand, understands what's going on here and updates his tests so that it doesn't depend upon the implementation details of something that he may not have any control over.
What could Gallant possibly have been working on that would cause him to fix this test?
Hash functions? I don't know.
So we come across this fairly regularly. Many of our hash functions are tagged specifically, may change at any time, right? Because we need to change the optimization properties or whatnot, right? Every single time that we do that, we find that Goofus has tests that depend upon the particular order that you traverse an unordered set.
For no good reason, right? I mean, there's no reason why his tag set should depend upon the ordering of the traversal order.
And if there is a good reason, he should use a different thing that promises to be stable.
Right. But by updating his tests to assume that, or to expect that the unordered elements are, and give the elements, right? He avoids the brittleness.
Right. Another way tests can be brittle, a very strong code smell, a very strong suggestion that your test is about to go in a bad way. It's when you start capturing the logs before you run your test.
How could this go wrong, Titus?
Well, Hyrum, let me tell you. Turns out I've edited file.cc once or twice. And if you change line numbers, add or remove lines above 421, this test in some far-off file fails, right? They didn't care about that line number, I guarantee. They only maybe even cared about file.cc, right? The interface that they're using is probably to blame to some extent, right? They had to go through some weird contortions to start capturing the logs and get to the point of doing this instead of, making a call and getting back an error, right? But so there was probably a call that was missing or lying about the error or something, right? There's probably an API bug in there somewhere that excuses why they did this. But this is still the wrong way to do that, right? A regular expression here would be far superior.
Yep.
Hyrum has a great story about image compression.
Yes. So I spent much longer than it needed to take to upgrade the image handling libraries, some of the image handling libraries at Google, right? And one of the reasons it took that long is because some people depend exactly on the sequence of bytes that happens to be generated by the image library, right? So imagine that the compression algorithm changes, gets improved, like generates a better image, right?
Oh.
Maybe one that looks like this. Notice the slide number changed, right? Instead of that.
We did actually encode 2 different versions of this image.
Yes, there's 2 different. These are different JPEGs, right? And the result is that more than one somebody's tests started failing when we changed the new compression algorithm. Right? Lots of Goofus, not lots of, just Goofus. Goofus will pre-compute the image that he's interested in. Right? Store it somewhere, and then run his image generation test and compare it against the pre-computed image.
Sometimes Goofus does this by running his code twice. I am not a fan.
Yes. The result is that the pre-computed image does not match the one that is now being generated by a more efficient compression algorithm. You have a smaller file, and you're complaining that your test now fails, right? Just one example of how brittle tests, updating stuff far away from the actual test, right, causes failures in tests.
So what he really wanted to do was to take some JPEG of Rick Astley, clearly, and convert it to a bitmap and store that as the golden output. And then write his test as, I get some JPEG of Rick Astley, I convert it to a bitmap, and then I delta between those, and so long as each pixel is within epsilon, right, then I probably got the right encoding. At least up until the point that we have enough AI to recognize, just assert, this is a picture of Rick Astley.
Next year.
That'll be cool.
Yeah.
But the notion of run your code twice, once to store this is the output that I expect to always be there for all time, and then do the same thing every time you run the test, that should be a serious red flag, right? I know I've done it. It's not the right thing to be doing, right? If you can't compute from first principles what the correct answer should have been, your whole system is a little complicated, right? But that's okay. It happens. What you probably want to do is express some boundaries of what do you think is tolerable given what you do know about the system. And if you can't even do that, if all you can do is, I wrote the thing, I ran it, I got an output, I think it's right, I'm going to declare that it's right, you probably want to leave a comment in there explaining the journey of self-discovery that led you to this poor life choice, so that when something changes in a couple weeks or couple months and someone has to go look at what's going wrong, you've at least left them a hint, because it may be you, that no, I don't promise that the correct answer is 5.73 Rick Astley's, right? You say, like, my best estimate is this. If this changes, try recomputing here or look up, read this paper, that sort of thing, right? Just running it twice, not the best plan.
So ordering, right? This is a fairly simplistic example, but...
You don't say.
Yes, I do say. So the second test obviously depends on the first test, right? So the first test changes state in a global variable, right? And the second test depends upon the fact that that state has changed, right? This is all well and good as long as your test infrastructure runs tests in a predictable way, and as long as no one ever breathes on it again, right? As soon as somebody walks briskly past your desk and the air eddies touch your keyboard, this test starts failing, right? Because you start changing the way that the global state is mutated, right? And while this may be a little bit simplistic, think about things like, I don't know, changing the system clock, or touching files in the file system, or reaching out and touching state in a production server, or I don't know, I could go on. Like, there are tons of ways in which you can modify global state in your tests, and having tests depend upon said modified global state is usually a bad idea.
Your test is both brittle, and you are failing to convey all of the details of the test, right? You're definitely failing at readability to some extent because you have hidden dependency on, oh yeah, the other part of this test must have run first. We see this really most commonly not with global ints, but with data written to the file system by a test. We run most of our tests in TempFS, so they have access to in-memory file systems that are fresh each time you run the test. That's good, except each individual test within a binary doesn't get a fresh copy. So there's been instances for sure of tests that write out file state and depend upon it in funny ways. Then there's, of course, everyone knows, your test should be hermetic, right? Don't call out to production services. Try to avoid actually doing file I/O to disks. Try to avoid touching the network in any way. The more that you actually have ones and zeros escaping from your process, the less likely it is that your test is going to survive the future. This test you may have written, and this test will work until you hire...
We're not pointing fingers here. This is Goofus that wrote
this. Goofus wrote this, and it worked fine until we hired a second person. Right? You can only expect that storing data to a production service works if only one copy of that test is ever running at a time. Right?
So once you add continuous integration into the mix,
this is not a good plan.
This starts failing.
And then there's deep dependence and mocks. This is kind of a personal thing for me. So mocks are kind of amazing. And every test framework that we've seen has some notion of how to do this well. The talks on unit testing yesterday were talking about mocks and the like. So that's fine, except for it can go horribly, horribly wrong. So long ago, class file had a stat. And it had an output parameter for, okay, here's the result. At some point, we had some storage system, I don't know what, that required us to sometimes pass in options for this. And as sensible, no, as unwise, but pragmatic and quick software engineers, what we did was we just implemented a new stat with options, and we had a default behavior in the parent class of ignore the options and call stat, okay? You can imagine having done this. You've probably done this. Now, the problem becomes that someone in a Leaf project will write a test that is using a mock file and will expect that because of a call to stat with options, there is a call to the single parameter stat. Right? So some far off project has this test added to it. This means this test will fail if the file they are using, be it because of derived behavior from the parent class, or just whatever file type they happened to pick up, at any point implements stat with options directly. Right? That is, this test forbids the implementers of the file that they use from ever actually doing the thing they wanted. Right? You see that? Don't do that. Right? They don't actually care that the one parameter stat was called. They're just saying, most of the time, if it was called, I'd like something to happen. Right? They've totally failed at white box versus black box testing. They are peering deep into the innards here and then asserting behavioral requirements on the implementations that they're using. Right? This is a maintainer's nightmare.
Yes.
Anything more you want to say about that?
Don't do it. So the observation here is that if you have enough users, you're going to start seeing this. Right?
We actually have coined, he tried to name this something else. Around Google now we have a thing that we're calling Hyrum's law, which he originally tried to call the law of
implicit interfaces.
There you go. Which is?
Essentially, given an implementation, right, you have an explicit interface. It's a published interface. people should code to that interface. But sooner or later, they start depending upon the implicit guarantees of your implementation, whether it be speed or memory consumption or
File name and line number.
yeah, or file name and line number, or API call ordering, whatever it is, right? People will start depending upon this implicit interface, right?
So with a sufficient number
Given
of users,
enough users, pretty soon you will at some point have enough people using your system that the implementation becomes the implicit interface.
all right, there is nothing that you can change without breaking somebody.
Somebody will scream if you change any part of the implementation, right? This is a bad world to be in unless you've gone deaf to the screams. You can guess where I am these days. Right?
Goofus screams awfully loud for one guy. Anyway, we'll recap.
So, please write tests.
Please, please, please write tests.
Right. You need to be
Even
testing your
a
system.
bad test is on average better than no test at all.
Yes. It's possible to write negative value tests. It's
possible.
That's a whole nother talk.
Yeah, right? Write correct tests, right? Write tests that test what you wanted to test.
Write readable tests. Tests that are correct by inspection to your reader, which may be you in the future.
Write complete tests, test all your edge cases, and only yours, not everyone else's.
So use your tests to show how to use the API. That is, make sure your tests are demonstrative.
And please write resilient tests. They should be hermetic. They should not depend on anything else. And they should only break when there is an unacceptable behavioral change in something that you rely upon, right? And that is unacceptable behavioral change, not the file name and line number changed, okay? Please don't be Goofus. So we'll take questions. Do we have a mic, or should I repeat?
Yeah.
I'll repeat. Go ahead.
So you're talking about testing APIs. Who writes the tests for the API? The implementer of the API or somebody else?
So obviously this depends from organization to organization. And I totally understand.
So the question is,
right.
Who writes the tests of the API? Is it the implementer or somebody else?
Right, and this clearly depends on your organization. I totally understand the organizations that have split that responsibility into someone builds the test and someone builds the actual implementation. For us, it's almost always the developer in question, right? It is part of the initial change, like here is my change and here are the tests that go with it. Obviously, there is some variance in how religiously that is adhered to, but we generally, as an organization, do a really good job of it, holding the line of, no, you can't submit that without some change, or without some test. That tends to work pretty well, but there's a big difference between, yes, there is a test with this, and there is necessarily a good and well thought out test. Yes. So we definitely crossed the hurdle of, yes, we have a culture of tests. Tests are important. We believe that. That was a great thing to have fixed like a decade ago for us. We're still working on making it universal, the understanding of what is a good test. So there is room for advancement there. In the back.
What's your advice for a situation where you have a fairly complex piece of code that carries a reasonable amount of internal state? Now, wrapping public test classes into the privates to expose part of that state to be able to write an expressive test breaks one rule. Writing a test that says the world is round and has people on it feels not
Right.
right.
So the question there was, if I can paraphrase, how do you approach it when you have a large class with a lot of internal state, and therefore it's hard to have a nice, concise, readable, understandable test to do that without exposing some of that internal state? Did I get that reasonable? You'll note that we didn't call these rules. We did call these goals of good tests, and I don't know that you can necessarily always get all of them. And it is certainly the case that it is more important to have some testing than to say, it's too hard, I throw up my hands and go away. Right? That said, it does kind of get to the question of, if you can't write a test for it, was that the right design? And it is probably the case, I believe in tests first because that yields more testable APIs more than for any other reason. There's a lot of sunshine and apple pie, ponies and unicorns reasons to believe in test-driven development, but the thing that I think really shines, the thing that matters most is, if you wrote the tests before you wrote that interface, you wouldn't have written that interface. If it is too late, and many of the things that our team has inherited is far too late, then it is critical to just get anything in place, right? Get some tests down to make sure that you can make changes without breaking things, because you cannot maintain a code base, you cannot make changes to things without having tests in place, right? It is ludicrous to try to maintain a code base of any significance without having tests, regularly spaced throughout the entire space. Right? Does that get to it? Okay. So.
Right over here, please.
So you gave an example earlier of having an async operation. You have a sleep in there and it makes the test brittle. Totally agree. You've seen that everywhere.
Flaky.
Hate that. But what's the alternative? How do you address that?
So there's two things.
So the question is, with the test that had an async operation, right, you still want to be able to test asynchronous operations. How do you do that without making it flaky?
Right, and there's two things that test was really trying to get at. One was, this asynchronous operation can happen and generates correct results, hopefully, maybe. And two, is there maybe a timeout on it? Right? And you can address those two things either in the same test or separately, but you shouldn't be addressing them at the same moment. Right? What you probably want is some sort of actual synchronization mechanism, some callback from that interface to say, okay, I'm done. Right? You could have a callback with a timeout on it. Right? And if the timeout goes off, then the test fails. Right? You do also need to make it very clear that those timeouts need to be pretty large and only run in your kind of release profile. Right? We do a lot of stuff with the sanitizers, and when we were the first wave of get the sanitizers turned on everywhere was happening, the sanitizers have low but non-zero runtime overhead, and tests all over the place failed because they had timeout requirements in them. Right? They're you have to be done with this operation in this amount of time.
But we also see that with there are tests that will fail predictably at certain times of day. Right? So most of Google engineering is based in Mountain View, in the America-Los Angeles time zone, right? And that means that the build cluster is most heavily used when those engineers are awake, so between, say, noon and 8 p.m. So the build cluster is most heavily used during that kind of window in the day, and when that happens, tests will run a little bit slower because the cluster is a little bit overwhelmed, and if you have a test that has a timeout that's kind of right on that boundary, then during that time of day, those tests will fail. And when you run them at other times of day or over the weekend or what have you, those tests will succeed. And off the top of my head, I could name probably about a dozen subdirectories that I know will fail if I ran them right now. Right? And that wouldn't fail if I ran them in 12 hours.
This is particularly challenging because the stuff that we use for flaky accounting and bookkeeping depends on. And when we have spare cycles, we'll go rerun those. And you specifically have spare cycles when it's not that.
Yes, so you never run into the timeout issue when you have spare cycles.
Right, so they just get confusing. So, anyway. Does that get to your? Yeah. Mostly.
I mean, we have a lot of features, for example, so we wait on them,
Mm-hmm.
and we have the timeouts, so there is an venting mechanism there, so
Yep.
we're not waiting on them too long. But the only way we've been able to handle that, we run into the same problem when it's under load, then Valgrinder, the sanitizers, and our coverage tools also completely push through our timings.
Yep.
But the only way we found to handle that is to set just a really long timeout, like on the order of like 30 minutes, where normally the operation is, microseconds or milliseconds.
Right. And in my opinion, so the retort there was, when we're rerunning these things, then timeouts, or we just have to keep increasing the timeout and increasing the timeout in order for it to still pass reliably. When your test, if the intent of the test is to ensure that the thing runs quickly, then you only run that part once in a great while in release mode. If the intent of the test is not to enforce that this is a fast operation, then yeah, just set a ridiculously long but not insane timeout so that you don't get the flakiness, because a test that you can't trust is not providing you a lot of benefit. Right? As soon as you become inured to that test flaking from time to time,
It's invisible.
it becomes invisible to you. Right?
Back here.
So this is pretty close to what I was already going to ask, which is both technologically and socially, how do you actually code for flaky tests at like scale? And like if everything breaks at noon, how do you ever commit anything? Because then like, hey, guess what? It broke it.
You work out of the Pittsburgh office.
So the question there was, how do you deal both technologically and socially with the idea that there are flaky tests that are just kind of present, ever present?
So that's actually a big challenge on the work that we're doing, because we're working at the bottom of the stack, and our continuous integration tools allow us to run all the tests that transitively depend on the stuff that we're working on, right?
So it's very easy for me to commit a change to a comment that technically re-triggers 250,000 tests.
Yes, or more. Right?
Or more.
And so there's a couple ways of dealing with that. The obvious one that actually works relatively well is to ignore them. So now we're getting into the confessional mode of the talk. To ignore flaky tests. That's not ideal, right?
It's not ideal, but at the same time, everyone's going to say, I know what I'm doing. I'm changing my thing, but I know what I'm doing. I'm doing a safe thing. I don't even need to run the tests, but you should run the tests. We are changing things at the very bottom of the stack, right? If we change something in a way that's unacceptable, it
is unlikely that one test of 200,000 is going to break.
Right.
It's more likely that the whole world will break, right? And so it actually becomes easier to determine whether our particular change caused that test failure because it's flaky, or whether it actually caused a bona fide test failure.
Yeah.
Right? The social aspect of this is something that I'm trying to work on within Google to some degree, right? Is actually to push the pain of the flakes back onto the people that are writing the tests, right? And there's different ways of doing that, and some of that is
baseball bat.
Thanks, Goofus. There's different ways of doing that, but some of that involves, filing bugs against those teams, being vocal to them about, your tests are failing, and there's ways to do that, making it socially unacceptable to have flaky tests. It's actually surprising the number of people that actually, an empty bug queue matters as much as a green build, right? And so if you file a bug against them about flaky tests, that's actually an actual thing that they'll work on. The point was, how do you ever get anything committed? We have scripts and bots that'll run stuff overnight when the load is less and less likely to flake, or we can run our big set of 250,000 tests, and then only rerun the set that failed. And if you do that iteratively, then eventually you get down to like, you actually never get down to a 0. Like, I've never done that and gotten down to 0 test failures on a non-trivial set of tests. But it's because people keep adding new tests. But you can actually get to a point in which you can either verify by inspection or use other tools to determine that those are indeed flaky.
And sometimes you just think about it, because when you're like changing it, how command line flag parsing works in C++, when some random Java file system test fails, you're like, eh.
Unless you're...
Every once in a while that'll get us, but like...
Unless you're testing the way that Swig interacts.
Oh, yeah, no, Swig.
With file. Because then the Java failures actually matter, right? Because you've changed the interface between the C++ and the Java. The other thing that you can do is actually give... Oh, it just left me. I totally forgot.
It'll come back. We'll do a question.
Yeah.
Other
Other
questions?
questions? I'm sorry. Did that answer your question? All right.
What is it you do to stop Goofus from checking in new flaky brittle tests?
What do we use to stop Goofus from checking in new flaky and brittle tests?
So mostly code review.
Mostly code review, and in order to get the code reviewers to do the right things, there's a lot of education. So like our team has this weird role of both we maintain all of the kind of lowest level interfaces is very technical, like, we can make a couple typo change that breaks the world, but we also operate at a very high level doing essays and classes and training and outreach and education and things to try to affect change over the whole population. Because as it turns out, when you have a population of roughly 5,000 C++ engineers, you have to rely on kind of network effects, right? You teach all the new people, or you find all of the respected code reviewers and teach them in particular. And those sorts of hands-on things are what we find helps most.
So this actually illustrates an important point that...
If we can't automate the problem away.
Yeah, automation. That we didn't point out is this is what I was going to say, is tests are just a part of the solution, right? This is really a defense in depth situation, right? Mm-hmm. So everything from code review to proper testing to static analysis to dynamic analysis to stuff like the sanitizers to hardening your code to canarying to production monitoring, like all this stuff, right, is part of having a robust software system. And so,
hey, I'm talking about all of that on Thursday.
Yeah, the hope is that if someone commits a faulty test, or if your tests don't catch a bug, right, the stuff down the pipe eventually does, right? Yeah. And that certainly isn't, that sounds like a wing and a prayer, and on some level it is, right? Just like, but this is how, airplane, avionics work, right? It is just
defense in depth.
Defense in depth, right?
Yeah. So. Other questions? Yeah, wing and a prayer. Other questions? Yes, over there. Right. So the question is, how do you acculturate testing? How do you, start there to actually be a culture of tests? At some point, you have to convince the people in charge, like not the head engineers, maybe the head engineers, right? But like the VPs, the CEO, whatever, like whoever signs the checks, that this is actually harming us, right? Our ability to ship code correctly is slowed down because we cannot tell whether a change is correct, right? At some point, you have to get that sort of backing and then hold the line, right? No, we will not accept your critical change. We will not accept your feature. We will not accept your anything if it doesn't have associated tests, right? And you have to be strong, and you have to hold the line. This is tough for a couple weeks, and then it gets much easier. We have had I hear stories from all over the organization. I hear stories from little branch projects and people that spun off and came back and startups and all sorts of stuff. I have got 0 accounts of places where they're like, you know what? We're in a rush. We're just not going to worry about tests. And that working, right? That does not work, right? In every instance, when you are falling behind, the correct answer is to hold the line, right? There will be tests, and that will help your velocity come back up, right? It is not time lost. It is time spent, or it is time saved from the future, right? And you have to, if they don't believe it, then you have to start documenting like, okay, Bob made this change. 2 weeks later, bug was found, right?
We lost $10 million because of it.
Couldn't release, right? And you come back 3 months later with a rogues gallery of this would have been caught with unit tests. This would have been caught with unit tests. This would have been caught with an integration test, right? And you just have to hold the line. And it's tough, and it requires some bravery, and it is the thing that matters most if you want your organization to survive. If you're at a little startup and your expected lifespan is 2 years, survival is not actually the important part, right? Your code base can be a complete flaming pile so long as you get funding. Right? So you may want to take that into consideration, but you do have to survive long enough to get funding, so I would still suggest you write tests. But you can make that choice yourself. So I think we have time for one more. Yeah?
So where do you draw the line? So you say no commit without tests, and you earlier said you could add in or change a comment and then So where do you draw the line?
So every different teams at Google enforce this different ways. Our team. So the question is, where do you draw the line, right? If you just make a comment-only test or a comment-only change, like does that need to be tested? And so every team at Google enforces this different ways. Our team actually says every log message has to have a tested field, right? In which you describe the tests you ran, right?
Every,
and if it's
every commit message.
Every commit message, yeah. And if it's just a comment-only change, then it's okay to say like I built it to make sure that I didn't have a spurious character somewhere and like the build succeeded, right?
But if
that'll still go through continuous integration. It'll still go through the CI system on the back end, right? Which is nice. But the alternative is like I just re-implemented the entire way that the distributed file system works. Like I built it, right? Is not the right answer to how to test that, right? And so part of it's just relying upon the humans to do the right thing and the reviewers to review the right thing, right? And to enforce that.
Yeah, it turns out anything that's a functional change should be accompanied with a functional test. Anything that's a cosmetic change, probably skip it. It's not such a big deal. Depending, like comments, certainly. Reformatting, whatever. All right, build it, it's fine. A good place to start is you can't mark a bug fixed until there is a test that would have caught the bug. Right? Because you're not sure you actually fixed it until you can demonstrate that. Right?
Which is the reason you write the test before you fix the bug.
Yeah, which is the reason to write the test before you fix the bug. Anyway, we are out of time. We will gladly stand around and chat more about tests. Thank you all very much for your afternoon.